Welcome to Wildcat Science with Mrs. Haugo. This is Physical Science, Chapter 1 on Forces, and we are in 1.3, Hooke's Law, Part 3. Previously, in Part 2, we started working on our questions. So please open up your Google document with your questions, and you should have number 6 done with a graph, and C answered, and D answered. And today we're going to work on 7. So it says examine the Newton scales on the 5 Newton and 10 Newton spring scales. Make the necessary measurements to draw the stretch versus weight graph for each spring scale. What is the proportionality constant for each spring? So A, using your data, make a table similar to table 1.2 for the 5 Newton spring scale. So I will be giving you some data today, so let's scroll down to the answers. And the total weight, as we can see, which you can't see, you'll just have to believe me, is now measured in newtons, which we know Newton is the unit for force. And it's a lot better unit than using a special water weight unit that is different for everybody else. In the science world, we need a standard unit, and our standard unit is newtons. So it's going to go 0, 1, 2, 3, 4, and 5 newtons. And then our stretch, which when it goes down, let's see if you can see that, when I pull the plunger down with 1 Newton, then it went down 10 millimeters. Oops, we got to start with 0. It'll be 0. Then it went down 10 millimeters. And when I pull it down with 2 newtons of force, I get 21 millimeters. When I pull on the spring scale with 3 newtons of force, I get a stretch of 31 millimeters, and I know this because I measured it. And 4 newtons, pulling down 4 newtons, gives a stretch of 41 millimeters, and then 5 newtons of force, pulling down with 5 newtons of force, gives me a stretch of 51 millimeters. And we should go back and put in all of our units. Millimeters, millimeters, and millimeters. And then our weight, or force, is measured in newtons. Great. Okay, now we're going to move on to B. Then graph the total stretch versus total weight for the 5 Newton spring scale using the graphing website. So we'll want to go back to that same website we were at before. And if you remember, we went on an XY graph, and we wanted it to be line, and then we have to enter our data. So now our data is again going to be the total stretch versus the total weight, and our x-axis is also going to be total weight, except now we're working in newtons because we're using that standard unit. And our y-axis is again going to be the total stretch. Now let's make it both capital. Stretch, and we're measuring it in millimeters. And we're going to have 6 points, and it's going to think a little bit, and then I'll want to enter my x, starting with 0, 0, x and y, all the way up to 5 and 52 millimeters. So you want to add in your data there, and then a minimum x value of 0, a minimum y value of 0, and a minimum x value of a maximum x value of 5, and a maximum y value of 55, which is bigger than 52 and a nice round number. And then we go to our preview and we get a graph, and we'll want to check that it has all the things that we need: a title, label with units, and data. And remember, I'm going to right click to copy the image, and I'm going to go back to my questions, and I'm going to go down to B, and where it says insert your graph, I'm going to paste it in there. Great. Moving on to C, it says calculate the proportionality constant for the 5 Newton spring scale. So we go down to where our answers are, and again the proportionality constant is equal to the total stretch over the total weight, and proportionality constant equals, this is where I sub in my numbers, and would want to pick a number that is nice and right on the line. So coming over here, our total stretch is 52 millimeters, and our total weight is 5 newtons. So I will put my total stretch here at the top and then do my right arrow to go to the total weight, which is 5 newtons, and then down to go to the proportionality constant where I put my answer, divide it out, get an answer, and then my units, remember, will be millimeters per newton. And then you want to write it in a race sentence. The proportionality constant for the 5 Newton spring scale is, with your number with units. All right, please do that. So once you have an answer for C, we're ready to move on to D. Using your data, make a table similar to 1.2 for the 10 Newton spring scale. So we'll go down to our answers, and we have our table for the 10 Newton spring scale. Total weight, well, it's going to go 0 newtons. Just go ahead and do that now. 1 newtons, 2 newtons, 3 newtons, 4 newtons, and 5 newtons. And oh no, it runs out after 5 newtons, but I'm supposed to do 10 newtons. What do? Give up and go home, stay home? No. What you do is you are going to insert, right click, and then insert a row beneath. And we're actually going to need 5 total rows. So I'm going to highlight 4 more. 1, 2, 3, 4. And insert 4 rows below. There we go. Now we can continue just like it was always good to go. 6 newtons, 7 newtons, 8 newtons, 9 newtons, and 10 newtons. And then our stretch. So 0 is always going to be 0 millimeters. And then with my 10 Newton spring scale, if we were to measure the distance between 0 and 1, it would be 6 millimeters of stretch. A force of 2 newtons would be a 10 millimeter stretch. A force of 3 newtons would be a 16 millimeter stretch. And a force of 4 newtons would be a 21 millimeter stretch. And 5 newtons would be a 26 millimeter stretch. 6 newtons, 31 millimeters. 7 newtons, 36 millimeters. 8 newtons, 41 millimeters. 9 newtons, 46 millimeters. And 10 newtons, 52 millimeters. Okay, now we're done with our data table. We go back to our directions for E, Then graph the total stretch versus total weight for the 10 Newton spring scale using the graphing website. Okay, to make a new graph, you will want to start over. And we're going to pick an XY. We're going to do a line and data. We want to enter our, and you'll want to enter your data just like before. Graph title, total stretch versus total weight. The x-axis is total weight in newtons. The y-axis is total stretch in millimeters. And now this time we have 11 points instead of 5. We have 1 through 10 plus 0. And then you want to enter your data just like we did before. And then go to preview. And you'll have your graph, total stretch versus total weight. And looking here, total stretch and total weight. And you'll want to copy and paste it just like you did before into your Google Docs for letter E. And then you're going to be doing a proportionality constant again, where you're going to, there's the formula, and then down here you're going to be entering the total stretch up on the top, and then the total weight on the bottom, and then your answer with units again, millimeters per Newton, and then using a race sentence. The proportionality constant for the 10 Newton spring scale is your answer with units. Okay, good job. Number 7 was quite a long problem. Now moving on to number 8. The perimeter of a square equals 4 times the length of the side of the square. In other words, the perimeter of the square is proportional to the length of its side. What is the proportionality constant of this relationship? Well, we know from our answers that a proportionality constant is equal to the perimeter divided by the length of a side. So let's take a look at some. So we know from this diagram that the length of a side is 4, let's say 4 meters. And so what is perimeter? Well, perimeter is the distance around an object. So 4 plus 4 plus 4 plus 4. So coming back to our question, our perimeter we're going to put here. We know it was 4 plus 4 plus 4 plus 4, 16 meters. And the length of a side we know was 4 meters. And then we divide that out and we put our answer here. And our answer actually does not have a unit because the meters and meters cancel. It's a pure number. So you put it in the race sentence there. Then we go back and do B. Could this proportionality be verified by an experiment? Explain. Well, could you get a bunch of squares and measure the lengths of their sides and their perimeters and then divide them and see if you got the same proportionality constant? They're asking, could you do the experiment? Explain. And then C, is this relationship limited to squares of a certain size? Now, do small squares have a certain proportionality constant and big squares have another? Let's take a look at some examples. Okay, so if you're not quite sure if the small and medium square would have the same proportionality constant as the large square, you can always go through some examples. So figure out the perimeter of this and then divide it by the length of its side, which is 1, and see if you get the same proportionality constant as you did in A. And then find the perimeter of this one and divide it by the length of its side, which is 2 meters, and then figure out your proportionality constant and see if it's the same as you got with the big square. Okay, for B and C, you'll want to put a couple of one race sentence and explain in each B and C, and then we will be done with our 1.3 section. Good job!